Student, in this video, we will learn how to use integration to find areas bounded by graph. If we are given a diagram like this, in this diagram, we can see two areas, A1 and A2. A1 is above the x-axis, A2 is below the x-axis. The definite integral is positive for area above the x-axis. However, the definite integral is negative for area below the x-axis. We say that the definite integral calculates the sine area. If we want to calculate the actual area, for example, area A1, we can just integrate the function of fx from a to b with respect to x. If we want to calculate A2, what we can do is we find the absolute value of the definite integral. Okay, or we can calculate from right to left, from C to B, right to left, the definite integral. Or we can change the sign for area below the x-axis. Now, the next question is, how can we find total area? We know total area is equals to A1 plus A2. So, total area can be found by adding A1 to the absolute value of the definite integral from B to C, or we can use A1 plus the definite integral of fx from C to B, or we use A1 minus the definite integral of fx from B to C. Let's look at one example now. In this example, we wanted to calculate area bounded by the function and the x-axis. As we do not know how the area looks like at this moment, so we need to sketch the graph and determine the area that we wanted to calculate. We can start by finding the x-intercepts or zeros. When we equal the y to 0, we have three x-intercepts, namely -2, 2, and 4. Next, we can find the y-intercept. We can substitute x equal to 0 in the function and we get y equal to 16. So this is y-intercept. Now we can sketch the graph. So we can see that the area is divided into two parts. One part is above the x-axis, the other part is below the x-axis. Finally, we can calculate the total area. So the first part is for the area above the x-axis. The second part is for the area below the x-axis. And this is the total area. We will now learn how to calculate area between curves. So we have two diagrams here. We can see an area bounded by two curves, namely y equal to fx and y equal to gx. Y equal to fx is the curve above the area, and y equal to gx is the curve below the area. So we can see that y equal to fx and y equal to gx intersecting at x equals to a and x equals to b respectively. So the shaded area can be calculated by finding the definite integral of fx minus gx from a to b with respect to x. So please take note that we use the function above the area minus the function below the area. What if we have area between curves that look like this? We can see that the area is divided into two parts, namely A1 and A2. How do we find the total area or the shaded area? So we can start by finding the intersection of the curve. In this case, we need to solve fx equal to gx. So we only need the x coordinate for the intersection point. Okay, so we will do that. So let's say A is the x coordinate for one of the intersection point, and B is the x coordinate for another intersection point, and C is the third x coordinate of the intersection point. So we can see that the two curves y equal to gx and y equal to fx intersect at x equal to A, x equal to B, and x equal to C respectively. So we can now find the area of the shaded region by adding A1 and A2. Okay, so A1 is the definite integral of gx minus fx from A to B. Please take note that gx is above area A1 and fx is below area A1. So we use the function above minus the function below. For A2, A2 is the definite integral of fx minus gx from B to C. So fx is the function above the area A2 and gx is below the area A2. Again, we use the function above minus the function below. In this example, in order to find the shaded area, we need the intersection point between the curve and the straight line. So the intersection point is here, and the coordinate is given 2, 2. So the x coordinate is 2. Okay, so we can now find the area of the shaded region by finding the definite integral of 6 minus x squared minus x from 0 to 2 with respect to x. So please take note that 6 minus x squared is the function above the shaded area, and x is the function below the shaded area. So if we evaluate the definite integral of the function above minus the function below from 0 to 2, we will get an area of 7 and 1/3 unit square.